Check the mic's working. It is good. I'm Dan Wright from ModWright, and I'm not a public speaker, so bear with me today, all right? I prepared for this, and we'll just see how it goes. But tubes and solid-state technology, how they work combined for best sound. And one of the premises I wrote up here, if you can read my chicken scratch, solid-state amplifies current, and tubes amplify voltage. And that's pretty key to explaining why solid-state works the way it does and why tubes work the way they do, and how I use them both, okay? So, first of all, we're talking about which is best, tube or solid-state, and John's laughing at me because he knows I'm going to start a fight. No, it's not a matter of which is best, it's how people use them both. So, by show of hands, who is tube only here, okay? Who is solid-state only? And who uses both? Exactly. Okay, made my point for me already. All right. All right. Which is best, tube or solid state? As we both know, they each have their strengths. Solid state has good bass. It's quiet. It's fast and detailed. Can be harsh or bright if not done properly. Conversely, tubes have good tone, good warmth, lack of edge or glare, and the even order harmonics and the even order distortion is very pleasing to the ear. So we know these things. And starting with my history of audio, my first amplifiers were like Sony and Adcom way back in the day, and followed by a Jolita tube amp. So they both did great things. And I went from loving solid state to loving tube, and then saying, well, something's missing from each. So, look at the history. Sorry, boring part. History of tubes, 1912, I guess the first tubes were used. Western Electric, JBL, Altec, of course, we all know this. They worked because the speakers were designed to be driven by a handful of watts, horn speakers, etc. And the transducer, the relationship between transducer, the driver, and the output transformer is critical. In those days, they knew that, and they worked well together, etc. So, for a long time, 2, 5, 10 watts was ideal. In the 50s, 60s actually, with the advent of Fisher, Yamaha in 74, and even Sony's Class D in 78, we saw a shift, of course, to solid state. And the first solid state, I'm told, wasn't that great. They designed it as though they were tubes, and it's a different way of doing things. Lighter, cooler, less maintenance, of course. So I wrote a solid state is so much better. Why aren't all amps solid state? And for a time, I'm sure they thought all amps would be solid state from the 60s on. I think we all have had the experience that an all solid state system can be great, but we find we lack the body, we lack the tonality, we lack the experience, if you will, of tubes. Conversely, my experience with an all tube system has been, and not if done properly, but if not done properly, it can be a beautiful mid-range. Highs are good, but can be recessed. Bass can be lacking. And now, the exception to that would be for our all tube users here with speakers that are very compatible, it sounds wonderful. But otherwise, we find ourselves it not being ideal. It's going to be a short talk, so anyway. The thrust of the talk, really, and what I wanted to, and I'll open up for Q&A a bit as well, is the fact that we don't really have to choose, right? At the show here, I'm using tube source, tube preamp, solid-state amplification. And I find that a combination of the two is best. Starting even from the internal builds of amplifiers. The first tube amps were all tube. Everything about them was tube. Tube rectifiers, tube regulators, tube amplification. Now, if you look inside of an audio research or similar, you will find a lot of solid-state components, you know, because it's necessary and it works. It can make things better. So, a lot of stuff I wrote down is pretty obvious. You're like, why are you talking about this? As solid-state amps became popular, I think speaker designs changed. And we got to the point where, you know, an 84 dB speaker, like an Acoustat or something like that, needed, you know, 500 watts. So we kind of went the wrong way, I think, with that. I like to think we've come back from that in some ways. But what I saw, and one of the reasons I stopped doing tube amp designs was I didn't want to be limited to a specific speaker or a specific efficiency or style of speaker. So, ultimately what I found is that, and I start with saying that solid state amplifies current and tubes amplify voltage, because a solid state device is just that. It's a current amplifier. A transistor amplifies current very well. A vacuum tube amplifies voltage. And the relationship between current and voltage as it pertains to power is direct. Power times current, right? Voltage times current is power. So a tube amp operates at high voltage, low current. Solid state operates at low voltage, high current. And they both do these things very well. I have chosen to work with tubes in line level and preamps, and in these applications where you are amplifying the voltage of the signal, not current. And when it comes to solid state, again, that's why I like to use solid state for amplification. It's going to be a very short talk if you guys don't start asking me some questions. Yeah, very short talk.
There's some hybrid amps out there that are
Yes.
using tube for the gain stage on the power amp.
Correct. Correct.
That seems like it would be more in line with what you're talking about.
MOS code was a good example of that some time back. It was a MOSFET gain stage with solid, probably a tube gain stage with solid state output. The Butler Monad was the opposite. He was a solid state gain stage with a 300B power stage, which is interesting. I heard it sounded good. But yeah, you'll see we have a hybrid amplifier also, and it's the same way. You will put tubes in the preamp stage, but you'll use solid state. I like to use solid state devices in the power stage. So, I'm 7 minutes in. I'm sorry, I'm choking bad here. It's not my thing.
You're doing fine. Hey, I have a question for you. If
Yes.
you want to take a little bit of a break
Sure.
from that.
Sure.
Can you basically tell us what you think about the different amplifier configurations? Class A,
Sure.
Class AB, Class D.
Sure.
You know, what are you finding? You know, I've heard some Class D amplification that's sounding pretty good these days.
Yes.
You know, I think my days of Class D just can't possibly be any good or over.
Right.
Right?
Right.
You know, I've heard some GANFET things. I've heard some, you know, ones that sound pretty damn good.
Right.
What are you finding? What are your preferences based on the fact you get so much knowledge with multiple design criteria? What's your thoughts?
I agree. My early Class D experience was not great. However, Channel Allen's audio, a friend of mine, has done some great work. Linear power supplies and switching amplifiers, and it works well. Class D, as most of you know, you're switching the frequency very quickly, and basically it's almost like recreating a digital signal in that you have to filter all the noise, etc. So it's efficient, yes, and you can get a lot of power in a very small package. My opinion, the reason it doesn't sound good or sound natural is filtering out that high frequency noise. The human ear is far better measurement tool than any that we have. So I agree Class D is getting better. GANFET is raising the sampling frequency, or the operating frequency in this case actually. And so it's getting better, much like DSD and higher resolution digital. I'm not sure if I will design with Class D or not, but it is getting much better, you're right. Class A and Class AB, whether it's tube or solid state, Class AB makes a lot of sense in that, I'm trying to think how much to explain here, how deep to go into this, but most of you already know what I'm talking about. In a Class B amplifier, the plus and minus stage, one is switching on, one is switching off. And you get distortion where those transistors are switching on and off. With Class AB, you have an overlap where one device is on before it shuts off, the next device turns on. And in pure Class A, all the devices are on all the time. So picture a car that idles at 4,000 RPM. That's basically what a Class A, or 5,000, right? That's what a Class A amp is. So I've been doing some research into design topologies. Class B, if done properly, can be quite good, but limiting the distortion is tricky. I heard a Playback Designs amp years ago. He said Class B, and I'm like, what? It was wonderful. So it can be done. Class A is wonderful, but it's very inefficient, of course.
Eats up your room.
It does. Yeah,
Unless you have a sliding bias scheme.
For sure. And that's a whole different, you get into Class G and Class H, there's amps, this is bizarre, where your rail voltage can shift up and down with the operating point. Like getting too technical, but you can do more with the same limitations. So having done some work with Class A recently, it is very good. It's just at what point does it become inefficient? You know, at 100 watts Class A, you get a pretty toasty room. I think 30, 40, 50 watts Class A is good. I think it's a reasonable area, yeah.
Related to that, Dan, I've heard, 30-watt Class A amplifiers that sound like 100-watt Class A amplifiers.
Sure.
They seem to have more power for their stated wattage. Why is that?
Most likely solid state. Tube can be also, and I say that because a solid state amp.
Yeah, comparing solid state.
Okay, yeah. Solid state Class A. Well, it's a high current design, and that also means the transformer probably has much higher capacity current as well. So as your load decreases, of course, your current, your power doubles. For instance, a 30-watt Class A amp, 50, 60 watts into 4 ohm. It might still only be 30 watts into Class A, but the extra power is there instantaneously, and it still sounds like Class A. So I think it has a lot to do with the current capacity of the amplifier, the transformer, and the stored capacitance, etc. If it's good power supply design with adequate current, it'll sound much more powerful than it really is. Yeah. But a tube Class A, you're limited by the output transformer, and 4 ohms is not any benefit to you unless the transformer is wired for 4 ohms. I built 30-watt tube amps years back at 845s. I've done a few others, even 300B, and it's not the same as 30-watt Class A solid state. It's just not. So.
But it clips softer.
It does. Yeah, it does. What's hard, though, is to educate the consumer about the benefits of a low-power Class A amp. From a manufacturing standpoint, I say, okay, I've got a 100-watt amp, say, Class AB. I could build that same product at 30 watts. It costs me the same. But a 30-watt Class A version would sound a lot better. And it's hard then to market that to the public, right? Say, well, this product costs X and it's 100 watts. This product costs the same and it's 30 watts. So.
Although the industry is selling 5-watt per channel single-ended
right.
tube amplifiers.
Right, for sure.
Use with clips and some other efficient
loudspeakers. For sure, yeah.
30 watts is
right.
well done with good current
yes.
capability.
Yes.
Not to be shy about it. Yeah, pretty
right.
much. Unless you got a speaker below 85 dB efficiency.
Right. And that's the thing is, part of what I was going to say in the talk was that as solid state became more prominent, speakers became less and less efficient. And marketing teams took over to the point that you need 100 watts. You need 1,000 watts for these speakers. Well, in reality, the amp's probably only delivering 5 to 10 watts on average. When that bass drum kicks in, you might have a split second of 100 watts of power, or 200 watts, or whatever it is. But generally speaking, we don't need the amount of power we think we do, if it's done properly. So you can design an amp that technically puts out 500 watts or whatever, but if it's not designed well, it won't it won't sound good. Conversely, a 30 watt Class A or 50 watt Class A designed very well will drive, the same speakers quite well.
Is there something in your production right now that fits that bill? Or is there something coming up in the ModWright world?
There is. I have a MOSFET design that's Class AB that's quite good. And I built a prototype Class A, much less power, but again, the same overall capacity. For instance, 30 watts Class A dissipates, 150 watts of heat or something like 5 times it's rated. So it's drawing, 150 watts of power all the time to provide 30 watts. A Class AB amp wants that same 150 watts of power, but it's differently. It's using it very much more efficiently. So that's why I say I'm working on it, but I have 2 designs that are the same weight, size, and cost to build, but one is 3.5 times the power. And so it's a marketing nightmare is what it really comes down to. Yeah.
You need some of my speakers to put up.
Right? Here's a really good Swiss speaker that's super efficient. Now, we're using Franco Serblins here that are what, 88, 89? I don't know what they're not super efficient. They're 4 ohm.
They sound good.
They sound wonderful.
Both sound good.
Wonderful.
Yeah.
And so yeah, I think people need to realize they don't need all this power. Class D makes it cheap and easy. It's great, 500,000 watts. Nothing wrong with that. I'm not saying Class D is bad, but yeah.
So say you've got a Class AB
Mm-hmm.
that's biased so that it's a Class A until say 40 watts.
Yes.
And it's a 300 watt amp.
Mm-hmm.
How would that compare in sound quality to a 40 watt Class A?
Well, see, that's a good question. In theory, it should be very similar, right? Because, like I said, in reality, you're only using 5-10 watts most of the time. And if the amp truly is Class A to the first 30 or 40 watts, then you're rarely leaving that window, ever.
It seems like the best of both worlds.
Absolutely. Absolutely. And it is a good way to go, for sure. Our AB amps are usually about 10-15% into Class A for that same reason. Yeah. It just makes sense. But there's a cost then even, though, too. Because a 300 watt amp, say it requires X amount of heatsink, that 40-50 watts probably takes the same amount of heatsink, quite frankly, just to idle and cool properly.
Yeah.
So, yeah.
It sucks a lot of power out of it.
Right.
Eats the room.
Right. Yeah.
You mentioned MOSFETs. Are you using them as output devices?
I am. I've used bipolar and MOSFETs for some time. Our first amps were only bipolar on semiconductor thermal track devices, which are great because they change bias quickly with operating temperature and the heat sink, and they work really well. I then have used modern MOSFETs. They're vertical MOSFETs, what they refer to them as, using in switch mode power supplies, Class D amps. And these devices are meant to switch on and off very quickly. And they work fine for audio gear. The lateral MOSFET, which was used a lot in the 70s, 80s, and 90s, lateral, vertical, referring to how silicon die is laid out. Without a diagram, it doesn't make sense, but it just has to do with how the transistor is built.
Yeah, I remember the trend towards MOSFET amps.
Sure.
In the era you're talking about.
Yeah, in the 80s and 90s, they were Hitachi, Mitsubishi. These were great sounding MOSFETs.
And then it seems like most of what I'm seeing is going back to bipolar.
Yes, it went to bipolar, I think, because the lateral MOSFETs were not easy to come by. A company in England, Profusion is the parent company. Exicon is the manufacturer of the lateral MOSFETs that I use now. Vinny Rossi used them in his Brahma series, I believe. Some other manufacturers do as well. They sound phenomenal.
Yeah, I remember having trouble getting my hands on a bunch of B channels. I forget.
Right. Yeah, not many companies make them. We have pretty much sole source from a place in England, and if that didn't work out, then we'd have to change the design.
Great. We're talking about voltage. FETs are voltage devices.
Sure.
So, but then of course all the circuitry before it is, on the pre-drive and drive. So
Right.
it looks like a Class AB amp to me, right? So,
Mhm.
so what would be your advantage of using MOSFET?
Well, MOSFETs and bipolar, they're both transistors and operate in the same way. They both amplify current, as I say. The biggest difference really is sonically and how they operate with respect to temperature. bipolar devices will operate differently when they heat up. It affects the current, it affects numerous things, whereas MOSFETs don't. They're just rock solid. So there's some differences there. Sonically, operationally, MOSFETs are more stable for Class A use. That's why you typically see them in Class A amps. They don't go into thermal runaway, whereas a bipolar can. The bipolar device, as it gets hotter, it wants to pass more current. And so if it gets hotter, passes more current, pretty soon it blows up, right? Whereas, yeah, exactly. The bipolars we used from onsemi had thermal bias diodes on the die. So as the heatsink heated up, the die was like, yep, throttle it back, throttle it back, throttle it back, right there. And that's why they work really well. But even then, if they stayed hot for too long, they would be stressed and we'd have to replace them. So, whereas a MOSFET, you can heat it up all day long until it blows up. It doesn't care, right? And they're very stable. So that's why PASS uses MOSFETs. And but yeah, MOSFET versus bipolar, it's a good question. My Hong Kong distributor said, "Oh, people want MOSFET. I wanted bipolar." I said, "Okay." Not for any good reason, except for the fact that they're told it's better. Right. Right. Yeah.
Because I thought that was one of the advantages of bipolar with the newer MOSFETs, not as linear.
I'm sorry. What was that again?
I've heard that a lot of the newer, more available MOSFETs aren't as linear.
Well, the current production, I don't think are quite as good. The vertical MOSFETs, the old technology being remade, the lateral MOSFETs I think are very linear and are very good. I will use them, or I will use bipolar, but I won't use a vertical MOSFET, and they just don't sound as good, quite frankly. So yeah.
Can you talk at all about your bridge module and how sticking the tube bridge in the middle fits into your discussion of the
Absolutely. Absolutely.
technologies?
The analog bridge is a product we made that basically was to take the place of, we used to modify digital players, Sony, Oppo, Denon, CD players for years. Many people that know me know this. And when Oppo went out of business, that was kind of the last company to make a good CD player or DVD player, Universal. And so I'm like, well, what are we going to do as far as that part of our business? And I said, why don't we make a tube stage that you can use with any source, CD player, DAC, or anything. So the analog bridge became that product. By its very nature, it's a buffer. And I say buffer, and people go, oh yeah, okay. Unfortunately, buffers have a bad name. In its basis form, a poorly done buffer it's okay. It's not great. It's a unity gain stage. Tends to be low distortion, but it can be high distortion. It can be very noisy. So you go to Amazon, you can buy a buffer for like $50. It'll make things sound warm and fuzzy, and won't be good, but it'll be warm, right? So I set out to design a buffer that would be exceptional, and it took a while. This one's got bandwidth flat to 200 kilohertz, 20 to 200. Distortion is like 0.005%, which for tubes is very, very good. Dead quiet, and so that's why I did it. As to where it goes in the system, I always say no tubes, no magic. Somewhere, right, in the system. You started putting tubes in CD players back in the early 2000s. And again, it was great because it dealt with some of the problems, that edge, glare, etc. So a product like that could be used between the source and the preamp. It can be used between the preamp and the amp. Being a buffer, it has very, very low output impedance. So one ideal application would be, you've got a simple system with a source, a passive attenuator, whatever, high dollar DAC'd stepped attenuator thing. And if you don't have anything buffering between that and the amp, it's going to sound good, but it's going to sound lean because the impedance match is all wrong. If it's a 10K pot, then your output impedance is 10K. And the amp says, well, I'm 20K or 50K, so it's okay, but it's not great. So one ideal use for a product like the analog bridge is to put it between a passive attenuator, a passive pre, and the amp, or any other preamp and amp, or a digital source with volume control, because the output impedance of the bridge is like 20 ohms, so it's just not an issue.
So now there's a difference between building an Oppo and putting the analog tube stage in the box versus outside is I still have a solid state preamp in those boxes. So I've got the
Correct.
So I'm trying to get my head around, is it adding things or taking things away? I mean, it can't bring back whatever
Correct.
coldness.
Correct.
It can't undo that.
The mods replaced solid-state circuitry with tubes.
Right.
And it was not a buffer. It was gain and buffering a lot of things. So that is true. And it would be ideal to do that. But if you have a system and you love it, I don't want to change anything, but I want to have some three-dimensionality. You are adding something, but you're not adding noise. You're not adding appreciable or even measurable distortion, really. You're not limiting bandwidth. So do no harm is the first job of a product like that. And that's what I set out to make sure, was that it would not limit any of those things. Because you're right, you're adding something.
And what would you say that, in those terms, what term would you use to say what it's adding?
To me, it adds that tone, that body, that three-dimensionality. The sound stage, really, is what it adds.
Is that the even harmonics?
I think it's harmonics. You know, I don't have an exact answer for you, but tubes, like vibraphone music and stuff like that, or guitar that has a lot of harmonics, on tubes it sounds gorgeous. So the way tubes handle harmonics and the way our ears hear it is unique. So putting tubes in the system does give you that back, even though, like I say, you're adding something.
Right.
Because I know the thought process.
Makes me nervous to add
Sure,
something.
sure. Mm-hmm.
So just further to your, and pardon me, I'm no designer, but you're really just one step away from the source. You're coming out of a
Correct.
live stage. You're really, you're not messing with phase that much. You
No.
know, it's pretty much intact at
Correct.
that point.
Mhm.
And if I'm not mistaken, a tube is one of the only devices that will really reproduce the entire frequency range.
Correct.
Versus solid state devices that some would need to be layered to do that,
Right.
correct?
Correct.
That's one of the benefits of a tube. It's full frequency bandwidth from one device.
And the
So
reason,
harmonics might be because of the crossover distortion
sure,
between the solid state. It eliminates that.
Yeah.
And that's probably what gives it that holographic
Sure.
kind of. Am
Yeah.
I onto something here?
you know, you are absolutely. Most
Okay.
line level tube circuits that I use are all Class A, because they're not really generating any power. You know, a preamp doesn't need to deliver power. So it can operate in Class A and be a fraction of a watt or whatever. But it's always on. There's no crossover distortion, there's none of that. And a tube is a very, very simple device. I mean, a triode's got 3 parts and the signal's barely touched. But yeah, adding that body, that three-dimensionality, in the same way other people say, well, adding a transformer to the signal path is bad, right? Some of our products use transformers to couple, to split phase and combine phase. And I would argue that, yeah, you're adding, say, a mile of copper wire to it, and you're gaining things that are hard to accept or understand. The inductive quality of a transformer, it doesn't always, as audiophiles, we always think pure, better, less is more. And sometimes it is, not always. So, yeah.
I've been an advocate of the thermal track
Mhm.
of transistors.
Yeah. They're very good.
However, well, going back several years, they had a serious reliability problem, and it had to do with thermal stress on the die between the diode.
Where'd you hear this? Where did you hear this from? Because I've experienced it.
I've done thermal track
Okay.
amplifiers.
Yeah.
Air was using them, Macintosh, and there were numerous instances where, for some reason, the bias would suddenly and unexplainably change dramatically. That was a significant reliability problem. Have you used any thermal tracks since that, and has On Semiconductor fixed that problem, and are they still making them?
It's a good question. We changed from the 4281 and the 4302 to the 3281 and 1302. They did away with those old products. That could have been where they fixed it. I don't know.
Which
But
parts did you change to?
3281 and 1302. So virtually the
Those
same.
are the ones that I've always used.
Okay, well,
And you didn't run into reliability problems?
oh, we did in the past, yeah. Same thing. I had to bias my amps cooler and cooler. If they ran too hot, the diodes themselves would become stressed.
Yeah.
The BJT was fine, but the diode was stressed and it wouldn't hold bias. They do, and they do, and I've asked them, and they play dumb when I ask them. But I don't know if they fixed it or not. I've had less issues. I've had to go back and repair and replace transistors and amps from years ago.
Are you still making thermal track amplifiers?
We do. With the 150SC is one, and the 225 integrated also uses them. We've had no issues at all.
Oh, that's good to hear.
Yeah.
It sounds like they fixed it.
I think so. And we, like I said, we also backed the bias off where they weren't running as hot. So I don't know if they increased the threshold of reliability. They had to have, because a lot of people were using those. I don't see how they could have. Yes, they still are a great part.
They solved a very big problem.
For sure. Yeah. Going forward, based on my experience with these new MOSFETs, though, that's where I'm going to be designing around for all foreseeable future products.
Are these laterals or verticals?
They're laterals from Exicon. Yeah, they're great. Cost-wise, a little bit more money than the bipolars, but they're reliable. They hold up. They're you run them hot, no problem.
Yeah, they're very, very similar to the Hefflers.
Yeah.
Many years ago.
Yeah.
Those were good amplifiers.
Yeah, Mitsubishi and Toshiba made a lot of those. There's a couple of companies that were remaking them also that were fairly expensive, but Exicon is they seem to have good availability and yeah. So.
The Canadian company Class A used to, maybe they still do. They had a heater and a fan, so that they could lock in the temperature of the power
interesting.
transistors. So
Yeah.
they're always right at the sweet spot.
That is a good way to do it, except audiophiles don't like fans.
It was proportional to the amount of heat
Sure.
that's being dissipated. So
Yeah.
in principle, if you would only have the fan going at high speed,
Right.
if the music was playing really loud, so you still wouldn't hear
It can be thermostatically controlled for that matter.
It was.
Right.
It certainly was.
Makes perfect sense.
There's a problem with that approach, though, even if you don't care about the noise of the fan.
Mm-hmm.
That is that the fan is trying to control the temperature of the heat sink,
True.
which has a very long time constant.
True.
The solid state, the transistors have quite a short, and there's multiple time constants. And the fan's not going to do anything for that.
However, the on-semi devices in particular react really quickly.
Oh yeah, with the dot,
Right.
thermal track.
Right. What we're talking about really here is the heat sink, this big block of metal. It takes time. If you heat it up, it takes time for the metal to absorb all that energy. Right? Yeah, and so it doesn't cool down or heat up quickly. But the fan might cool the surface of the transistor quickly, but the heat sink's still hot. The on-semi devices do react quickly enough that it probably could work in that case. And as such, it sounds like a perfect engineering solution. But consumers want different things. So, yeah.
Nice plug for Class A, though.
It used a smaller heat sink, so it didn't have
Sure.
that thermal capacitance.
Yeah.
And I think they
That
probably
works.
used a temperature sensor close to the die.
I saw an early Class D design that had the heatsink was like a tube, had fins around it, and a fan that blew right through it, and the devices were attached. That was very smart because the mass was low relative to area, and it probably did manage to change the temperature quickly. Another argument for Class A, it's always hot all the time, so, right? As long as it's a MOSFET, it works fine. So.
I'll ask another question. Phil.
Sure.
This gentleman mentioned that sliding bias scheme on a Class A amp.
Yeah.
It seems very compelling. What's the downside for that?
I've not worked with it much. Anytime you add something that senses a circuit and causes it to adjust in real time, you're adding some complexity. Which things fail, they can fail badly. In theory, it should work very well. But a lot of it involves microprocessor control and monitoring and stuff, and the complexity is more than I want to deal with. Perhaps that's not how they're doing it. I don't know exactly.
Well, I've been involved with two companies that use it. One, Krell, with their iBias scheme, and the trick is to keep it out of the signal.
Right.
But that's
Sure.
done. Right?
Okay,
It's done.
that's great. Yeah.
And then the Infigo amplification uses its own proprietary sliding bias.
Sure, sure.
And it uses an even higher level controller.
Right.
But again,
Right.
staying out of the signal path.
Right,
is
absolutely.
The most important thing to do. They
And
both
that-
managed to do it and do it fairly well.
Absolutely. In theory, it should work, and it does work in practice. So clearly, it can be done. Yeah. I have not experimented with it personally. I try to keep my designs fairly simple and fairly simple from the standpoint of reliability. If I got a unit in East Asia, in China, and Hong Kong, and Russia, no technicians around, I want it to be pretty bomb-proof, right? Traveling on a truck through Mexico and getting dropped on the, by the time it gets there, you hope it still works. And so you got to be pretty rugged. Yeah.
So what's your thoughts on OTL tube amps?
I had an Atmosphere M60s years ago. Wonderful. The thing with those is they really want a high impedance speaker, 16, 32 ohm. Because again, the impedance match without a transformer to match the impedance, or without, solid state does it differently, but in tubes, typically the transformer is your impedance matching interface, right? With OTLs, you don't have that. So one fix was what the zeros, they call them, which is basically an autoformer. Okay, well, adding a transformer back to an OTL doesn't seem to make a lot of sense. The short answer, they sounded wonderful. They were hot. They were 60 watt pure class A, and they heated my room a lot. But bass was not great. Highs were good, very fast, very open, but bass was always lacking. And I didn't have speakers with 16 ohm impedance, so it wasn't ideal. Again, that's the problem I have with, and I'm not downing tube amp designs, just that from a manufacturing standpoint, you have to have a good match between speaker and amp. And Alltech and those guys, they did it inherently because they had to. But now with speaker designs moving forward with solid state in mind, it's more and more difficult. And so, finding that match is important.
It's all Hoffman's iron law, right? In terms of efficiency versus
Right.
bandwidth.
Yes. Yeah.
And that's what,
Yeah, for sure. Yeah. For sure. All right.
Thank you, man.
Thank you.